Everyone, welcome to another episode. I think again I am running 2 days behind, but let's not waste any time and move forward with the question. So today's question is: you're given an array of integers and an integer k. You need to find a total number of continuous subarrays whose sum equals to k. Okay, so you're given an array 1 comma 1 comma 1 and k equal to 2. So the output is 2. Why? Because one is this continuous subarray that gives me the total of 2, and the other one would be this, right? um, let's brainstorm the approach. I think I would try to take some other examples to see. 1 2 4 3 k equal to 3, right? So in our case, answer should be 2, because one is you can um, create this subarray like this, and then the other one would be this, right? So you can create two subarrays, uh, which sum is equal to 3. Now, how do we solve this problem? So uh, before jumping on the problem, I would like to see the constraints. So the constraints is given the array size is 1 to 20,000, and the range of the numbers is from -1000 to 1000, and range of k could be from -10 to the power of 7 to 10 to the power of 7. So generally, if you see this constraint, I think we should come up with the approach that is less than O of n square. Ideally O of n should pass. So the constraints help me in finding the complexity in which I should run the program. um, so let's see. uh, the general idea that is coming to my mind is to go is to use two pointer approach, right? So let's say I keep a sum equal to 0. My pointer starts at 1, so my sum becomes 1. Then I add 2, so it becomes 3. Now it's if sum is equal to k, right? If sum is equal to k, I need a count variable which is 0. So if this is equal to k, obviously I'll um, increment my count variable, which is count of the subarrays having sum k is 3. Now when I move forward, my sum becomes 3 plus 4 7, right? And then moving forward, my sum becomes 10. So what do we see here is, if we keep going the loop going, and if we keep the iteration going from 0 till the end of the array and keep incrementing the sum, these are the sums we get at each the end of the instances, right? Now we see that we get 3 here. That's good, while moving from 0 to a position here in case of 1. So because we are keeping sum while moving from left to right, the sum which will be equal to k will will happen only once, because sum is something that is keeping the variable counts from 0 till we reach the index I, right? So we are never gonna see this sum equals to k if we have already passed that k value, right? Now how do we figure out that there is a subarray with the same count as k? So when we are at 10, or better than that, yes, when we are at 10, I guess, if we subtract 3, which is this value, which is k value, right? K is 3. So if I subtract k, what do I get? I get 7. So now we see that 7 already had occurred somewhere, right? So So we are sure that if I am at this place and if I remove all the indexes that got me the sum 7, which is like in our case, if I remove all the indexes till here, like if I try to see that this is the starting value, and I just remove all the previous values that caused the sum till 7, I'm sure that there is another value 3 here, right? um, I think it will be more clear if we see one more input. So let me take little bigger numbers, and then I can be like 2 comma 1, and let me take k equal to 3. In this case my output should be count should be 2 final, right? Because one is this and then another is this. Now let's keep sum as first it becomes 1, then it becomes 3. So here we get the answer count equals to 1. Then we have 7, then 5 12, then 14, then at the last we have 15. Now see, what do we do at each step? We see if I do 7 minus k, I get 4. Did 4 occur anywhere previous to this value? No. So we don't increment count. Similarly, 12 minus k is 9. It didn't happen. 14 minus k is what? 11. It never occurred. Now 15 minus k is 12, right? So what I'm sure about, if I cross all the elements before 12, which is if I cross this element before 12, I'm pretty sure that this will make my count plus plus, right? Now there could be a case that 12 occurs twice. The count of 12 occurs twice. Like there could be 1 2 4 12, and then there is another 12 causing it to increase the sum, right? So let me think of an example that would cause that. Yeah, there has to be a negative value in that case. Yes, we'll see that. So in this case the count will be plus plus, correct? So count will become 2 here, and then that's why we can remove all these values that had occurred before here, and we can consider this as a subarray because this is a continuous part, right? This is being caused by 2, this is being caused by 1, so we get the 3, we add it here. I think we can take negative values example, which is 1 2 4 3. Let me not take 3. Yeah, 3 is fine. Then minus 3, and then 3 again. K is equal to 3. In our case the output should be 1 2 3 4 3, right? Because this is the answer, this is the answer, and this is the answer. So let me not clear. Let me take sum is equal to 1 equal to 3. Here the count becomes 1, then 7. 7 minus 3 is 4, we don't have it. Then here it becomes 10. 10 minus 3 is 7. Count is plus plus. Then we have 7 again, right? And then we have 3 again. 10 minus 3, which is 7. Correct. So in this case, 7 has occurred twice. Hmm. 4, 3, 7. Correct. The output should be 4. I'll tell you why. Because one is this subarray, right? One is this. One is this. And one is this whole subarray. Because the sum of this subarray is unique, and sum of this subarray is also 3, because minus 3 3 cancels them out, and there is 1 3, right? So because of the negative values, what we need to do is I keep track of all these intermediate sums also, because here 7 has been, count of 7 has been 1. When I do 10 minus 3, I see a 7. Okay, still this value there. If I remove all these values, I can get the sum 7. So I do a count equal to 2 here. But when 7 becomes 2 again, so when I see a 7 again, I'm sure of the fact that there is something that is causing the balance of the numbers, right? Which is like balancing 7 out. So here I increment the count of 7, like I keep a map and use 7, and now when I see 7 again, that 10 minus 3 is going to be a 7. So I do count plus equal to count which of 7 basically, which is 2 plus 2, which is 4. So what in short I'm trying to figure out is, because see, when I'm at this 3, I know if I remove these prefixes 1 2 and 4, I can get a sum of 3. So this is a subarray. Now when I am at this 3, right, there are two ways to receive the sum equal to 3. One is if I remove all of these, right, which will give me one count, and then another one is if I know, if I remove 7 from here as well, right, because these count of these is also 3. So this sum which I'm keeping track is keeping track of the values, or from 0 till this index I, right? So for when I reach these 3 also, if I'm getting 7 again, that means something in between balanced it out, and I can consider this whole as a subarray as well. So my count is not only plus plus. My count will be based on how many times this 10 minus k has occurred, right? So we need to use map. If it was only positive numbers, then my approach of count plus plus would work, because you blindly uh, do a plus plus, because count sum is always increasing. That is, you won't see a decrease or a dip in the sum. But in case of this, because of the negative values, you are gonna see it. So let's move on with the coding part. So now I need to take a map also. I'm taking unordered map because I don't care about the order, and unordered map is, I think, a little bit quicker than ordered map. Then if I'll do m of sum plus plus, and then here I will do return count. So I'm keeping track of all the sums, and if I see an intermediate sum, which is sum minus k, in our case we saw that when it's 10 minus k, which is 7, and 7 is occurred. So if we remove all the 7 values, the value till which we get 7, we get another continuous error, right? Let's run this code and see if it works. Okay, so it's wrong. What am I doing wrong here? If k sum is equals k, so initially nothing will be 0 equals to k, sum becomes 1, m of 1 becomes 1, and then I increment I. Maybe I need to do this. Okay. I need to increment the sum first. Awesome. So I had to add to the sum first, then only I'll be checking that value, right? I was checking that value, so it always is one cycle behind, and that's why I won't get the correct answer. Hope this approach was clear, and it was pretty straightforward question. If you guys like the video, please subscribe and give me a thumbs up. Thanks everyone.